channel. In today's video I want to talk about random forest. This is another supervised learning algorithm, and this is also an ensemble learning technique which uses multiple decision trees and takes a majority vote to reach a single decision. So let's get started. I need the libraries first. For NumPy, pandas, and from Scikit-Learn import label encoder. From Scikit-Learn.model selection import rendered test displayed. Random forest. Finally, from Scikit-Learn import matrix. Okay, so these are the libraries that I need for this example. Then I will use a secondary mushroom dataset. Let's read it using pandas. So this is available in the GitHub repository. Secondary mushroom dataset. Okay, so I have already loaded the dataset. I can see a few nan values in this column and in this one as well. So it has some nan values or null values. So let's check the shape. So the row is 61,069, column is 21. Okay, so let's check NA values. Okay, so it has 21 columns and cap surface has NA values. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Looks like 9 column has these NaN values. Dot sum 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, so this one has 14,000 NaN values out of 61,069. Some has really large NaN values like this one. It's more than 80%, I think, or close to 80%. This one also has huge null values. Okay, so what I'm going to do is I'm going to drop these columns that has null values or missing data. So drop null values. Let's call it drop df. Okay. Let's first check the columns. Okay, I have to copy this. test. So let's see which one has. So cap surface. So I am to keep this on since it has null values. Then GIL attachment. So these two doesn't have any null values. GIL attachment, then GIL spacing also. So I can keep this one. But GIL color, stem height, stem width. Okay. Stem root has, stem surface also has null values. Stem color doesn't have any. Field type, field color. Hasting doesn't have any null values. Ring type is for print color. Okay, these two also do not have any null values. So how many columns we got? 1 2 3 4 5 6 7 8 9. So it makes sense with this information. So I need to mention axis is equal to 1 to indicate that these are all columns. So drop df dot shape. So let's check head first. Okay, then check shape. So we have the same number of rows because we dropped columns, but instead of 21 we now have 12 because we dropped 9 columns here. Okay, also check info. So you can see non null, and the non-null equals the number of entries. So we do not have any NA values anymore. So NA values are gone. Then I want to perform preprocessing because I can see object here. So that means there are many categorical values in some of the columns. Perform preprocessing. Calls list. So I want to copy these columns and cap diameter has numerical values, stem height and stem width. So these three columns have numerical values, that's why we can say float 64, but others have categorical values, so we can say object in the D type. So I think I need to remove these two and cap diameter. Okay. So now I have probably 9 columns. So 1 2 3 4 5 6 7 8 9. Okay. Level encoder. Fit transform, then drop df. Okay, now we can see all the values are numerical. We do not have these categorical values anymore. Okay, the shape will be same. 12, previously it was also 12. we can also check info. So now we have integer 64 instead of object in the categorical columns. Now let's visualize selected features. Figure fix a 7/4 face color _scatter. So I have to select these two, stem height and stem width. Plus _PE _xlabel x-axis will be stem height, font width bold. This will be available. This will be and this will be selected feature visualization. Okay, pld.xtips pld.legend _legend elements, then title, font size 16, title font size 20. Something is wrong. Sorry, this is font. Okay, now you can see. So based on these two features, stem height and stem width, we have visualized the two classes that we have. So one is the poisonous and another one is the edible, and we can see there are very good overlaps based on these two features. but we will use all the features that we have except this one. This is the class. Okay, so now let's separate features and labels. Class will be dropped. Okay, so now the features and labels have been separated. Now split the dataset. Train test is split 0.2, train size 0.8, random state is 1. So we have 48,855 samples in the test set and 12,214 samples in the train set. Test set, and 48,855 in the train set. After 80-20 split. Okay, now it's time to apply random forest. So I will use 5 trees, which is the estimators parameter. I think by default it's much higher, so by default it's 100 actually, but I will use only 5. Then fit the train set on it. Okay, let's check the accuracy on the test set. Matrix dot rf.score. Sorry, forgot to put f here. Okay, so the accuracy is good. It's over 99%. Now let's plot confusion matrix. So 𝒚 matrix dot 𝒚test and 𝒚 and display variables rf dot classes, then disp dot plot cmap size 50. Just copy paste. So this will be prediction. This is ground truth. This is confusion matrix. Okay, so this is how the confusion matrix, sorry, also I forgot to change here as well, this title. Okay, now the title appears. So this is also title. Okay, so we had 12,214 samples in the test set, and here we have 40 wrong for class 0 and 59 wrong for class 1. So instead of 0 and 1, we can show the confusion matrix using the categorical labels. This is edible and poisonous. Now it's more clear. Now let's check few other metrics. We can check accuracy, white test, white rate, precision recall. So these scores are also high. So you can see accuracy based on recall all are well over 99%. F1 score also, and Jagged score is 98.55%. Let's print classification report. White test and white rate. So you can see scores are also all high. Finally, I have to plot feature importance. Importances indices. So input absolute figure fixer frames xtraining dot shape align center color blue edge color black pld.xtx so the forward to put bracket there. Indices rotation 90 pld.while label feature importance font size 14 font weight bold sorry extra bracket this is shape. Okay, so this is the feature importance plot. So dot columns, so we had all these columns, and the most important feature is stem width. So this one, then stem height. So how many columns so we have here? 1 2 3 4 5 6 7 8 9 10 11. So this one is class, so this will not be counted as feature. So we have 11 here, and stem width is the most important feature, then stem height, then others are gradually decreasing, and also the summation of all this is 1 obviously. Okay, so that's basically it. We can also plot the tree. So we have used 5 trees, I guess. So we can plot these trees, but since the number of samples is huge, actually it will be difficult to interpret in this for this dataset. So I'm not plotting that on. Okay, so that's the end of this video. Thanks for watching.